Today we're going to be talking about inductive reasoning. It's really important that you remember this is inductive reasoning because we have two types that we're going to talk about, and this is just the first one. So what is inductive reasoning? Inductive reasoning is going to use examples and patterns in order to draw a conclusion. Okay, so we're looking for examples and patterns, and those are going to be your key words here that you're looking for. So let's look at a couple of examples of inductive reasoning. So for example, I might have given you a list of numbers, okay, like this, and I might ask you what is the next number in the sequence. So you would be looking at these examples and you would be trying to figure out what's the pattern. So you would notice, okay, to go from 2 to 4, I had to add 2. To go from 4 to 6, I had to add 2. And so if I add 2 to the next one, I would get 8. And so I would know that 8 is the next number in the pattern. Okay? And this, what we normally would consider our answer, when we're talking about reasoning, this is our conjecture. We're saying that based on the information we've been given, that we believe 8 is the next answer. So a conjecture is going to be a statement that you believe is true, but you haven't proven it yet. So we haven't been able to prove that this has to be the right answer, but it's what we believe based on the information we've been given. Okay, this is more of a numerical example. You might also get something that's more of a picture. So I might give you some shapes like this, and I might ask you, what is the next shape in the series? And so you would say, okay, this is a triangle, and this is a quadrilateral, and this one is a pentagon. And so you'd think, okay, what do I know about these shapes? Okay, well, I know that a triangle has 3 sides. I know that a quadrilateral has 4 sides. And I know that a pentagon has 5 sides. So I'm looking to see what the next item in my list has to be. I can guess based on the information I've been given, the pattern I see, that I'm going to go up by 1 side. So I know that the next one, based on my pattern, my conjecture is the next one has to have 6 sides. And so I know that a 6-sided polygon, okay, because these are all polygons, has to be a hexagon. Okay, so I would know that that would be my next option. They might also give you this in word format. So instead of giving you pictures here, they might have listed out the shapes by their name. So they might have said, okay, I have a triangle, then I have a quadrilateral, then I have a pentagon. And they may ask you for 1 shape, or they might ask you for the next 2 shapes or more. And so your conjecture, again, is going to be what the next shape is. So again, you would say, okay, I have, this one has 3 sides, this one has 4 sides, this one has 5, so I know my next one has to have 6 sides, and then one after that would have to be 7 sides, because I'm just going up by 1 side each time. So these, my answers, are what we are calling a conjecture. Okay, it's a statement that I believe is true. Haven't been able to prove it yet, but I believe it's true. And it may be in word format, like it is down here, or it might be a picture, like it was up here. Okay? In order to make your conjecture, you have to provide examples that show that it's true. Okay? So when we're talking about examples, in a picture like this, it might be showing, okay, this one has 3 sides, this one has 4 sides, this one has 5 sides, and saying, okay, so I'm going up by 1 side. I'm saying this is plus 1 side each time. Okay, this is the equivalent of showing your work for these types of problems. Okay, for something like this, where we wrote the plus 2 down here on each of these, that would be the equivalent of showing your work. So we can see this is how it goes, how the pattern goes. Okay, it might mean giving several examples. So instead of just stopping at 8, it might ask you for 2 examples or 3 examples or more. just to show that the pattern continues in the same way. Okay. Now, we're also going to be talking about something called a counterexample. Okay, and you're going to have a foldable for this tomorrow. So if you would like to, your foldable is about 2 inches square, so you might want to leave a little bit of room there for that. And so a counterexample is going to be an example that proves a conjecture wrong. Okay, so not every conjecture is going to be correct. For example, I might give you a conjecture and ask you to identify a counterexample. So let's look at one of those. Okay, so on this one, I am giving you the information. I'm giving you the conjecture. So it says if, angle ABC is congruent to angle DBE, then angle ABC and DBE are vertical angles. Okay, so the conjecture portion of this is going to be the second part. So they're telling me the first part is true, angle ABC and angle DBE are congruent. And then I'm trying to provide a counterexample. So I'm trying to prove the second part, what I just underlined in yellow. I'm trying to prove that that is false. Okay, so my counterexample might be a picture. Okay, in this case, it has to be a picture. There's no other way to show that this is false. And so I'm trying to make it so that the first part is true. I want ABC and DBE, those angles, to be congruent, but I need them not to be vertical angles. Okay, so I'm thinking, okay, I've got these angles, and the angles themselves are congruent. Okay. And obviously, these are not all drawn to scale. They're as close as we can get them, just eyeballing it. And so I might say, okay, this angle is 50 degrees, and this angle is 50 degrees. Now let me see if my names can fit in there. So if this was angle ABC, okay, I'm going to switch colors just so you can see it, and this is angle DBE, I want to see if I have proven this statement up here false. Okay, so I have ABC and DBE are congruent, right? This first part, it's true. Good job. Okay. And then I'm trying to prove the second part false. So I'm saying ABC and DBE are vertical angles. They are not vertical angles. Remember, vertical angles are across from each other on an X. This is not an X here. So although these two angles are congruent, they are not vertical angles. So I have shown that the second part is wrong. So I made the first part right, the if part is right, and the second part is wrong. Okay? That means I provided a valid counterexample. Okay? If there is even one counterexample, then it means that the conjecture is false. Okay? It doesn't matter how many correct examples you could draw, because it is possible to draw this one where you have vertical angles and they're congruent and they're named ABC and DBE. It's possible to draw that. But if you can find even one example where it's false, then you would know that you have a counterexample. Okay? So, thank you for watching about inductive reasoning, and I will see you tomorrow in class.